All right, here we are on chapter 3. Go ahead and start with question 1. Our cat has a position given in polar coordinates. That means that the r value, or the radius, is 5.4 and theta is at 190 degrees. What is this position in polar coordinates? Okay, so if we were to draw this out, 190 degrees is going to refer to the positive x-axis, so we'd go up 90, we go over 180, 190 degrees will be something over here, and the radius on this is around 5.4 meters. So to go from polar into Cartesian, I can take this and I can draw, make it a little more of a triangular shape for you if you wish. Okay, it's not quite to scale, however. This piece up here, if it's 190 degrees away from 270, it means that this angle here would be 80 left over, so it'd be 80 degrees here. Which means over here this would be a 10-degree angle. We could also look at that if we chopped down here, that this angle must match that angle. So there's a couple different ways. If you want, you can solve this out. We know that the hypotenuse here is going to be 5.4, and we can use sine and cosine to determine the ends using whichever angle we want. Let's say that this is our x, this is our y. Traditionally, this is your x and this is your y. So the x distance here, I'm going to use the 10 degrees, being that's a little bit easier to get to. So I'll use the 10 degrees. So if I do that, this would be the adjacent end is what I'm looking for. So for that, I would need cosine. Because if you remember SOHCAHTOA, I want something that has the adjacent and the hypotenuse and the angle, because that's what I'm looking for, is the adjacent. I have the hypotenuse and I have the angle. Okay, so I'll use cosine for that, which means x. I can write it out for you for the first one. Let's see. It'll be cosine of the angle, so I'm going to use the 10-degree angle so that this x is on the adjacent. I know that's equal to the adjacent, so that would be x over the hypotenuse, which is 5.4. Solving for x, multiply both sides by 5.4, and you get x is equal to the r value, 5.4, times the cosine of 10 degrees. Okay. If you want to go ahead, plug that into a calculator, 5.4 times the cosine of 10 degrees will get you 5.3, and we're going to round that to 2, 5.32 meters. Okay, so that's the x position. For the y position, this would be the opposite. Okay, the opposite of the angle. So here's 10 degrees. This is on the opposite end of the triangle, so this would be opposite. So I'd be looking for the opposite given the hypotenuse and given the angle. So for y, I'm going to use sine. And likewise, it's the same process. Sine of the angle, 10 degrees, would be equal to y over 5.4. If I redo this for y, I get that y is equal to that r value, 5.4, times the sine of 10 degrees. Okay, so let's go ahead and plug that in. And we get that y is equal to 0.9, let's just round that to 4, 0.94. And that one's also in meters, okay, because the original r value was in meters. 0.94 meters. So now, some of this is correct and some of it is not. Okay, so on the x side, this is traveling in the negative direction. Likewise, if I would have used cosine of 190 here instead of cosine of 10, if you want to go ahead and try that, plug it in, you'll see that you get the exact same answer, but negative. So our final answer down here should be, I don't know, whatever this vector is here, we'll just call it vector A, is given by the x coordinate, so this would be a negative 5.32 in the x direction. You could use I direction, I hat, if you'd like. But this would be a negative because it is traveling in the negative x direction, Traditionally, these are both positive, traveling this way, and traveling up is positive. This one's traveling in the negative x direction. The y then is also traveling in the negative y direction. It's traveling downward. So we'd have 0.94 y hat. Or you could use j hat there if you wish. And that whole thing is in meters. Okay? So hopefully that made okay sense there, how you can do it a couple of different ways. You got to be careful for your signs, positives and negatives.